Good morning, everyone. I'm presenting you the data collection with the use of the LESSDRONE, and so the experimental data on the selected case studies. So the LESSDRONE is an automated and self-moving device that is able to move on the surface of the oxidation tank and is able to capture the off-gas. The LESSDRONE is it is propelled by 8 motors. It's possible to control the LESSDRONE a remote control by a controller, or else measurement path can be set by the use of a GPS. The instrument consists of a foldable steel support frame and that is carrying by 6 inflatable cylinders. There is a hood that is mounted at the center of the frame and conveys the off-gas into a collection pipe. On the upper part of the frame, there are 2 boxes containing the analysis instruments and the devices for the control and the positioning of the LESSDRONE. The gas passes by an anemometer to evaluate the airflow rate, and then passes through the sensors for the oxygen measurements and for the GHGS concentration measurements, so the CO2, the CH4 and N2O. There also is a probe for the DO and temperature measurements in the mixed liquor. The LESSDRONE evaluates the oxygen transfer efficiency in standard conditions and in processed water, the alpha SOTE, by using the off-gas method that is based on a mass balance in the gaseous phase between the oxygen content on the of the reference gas, that is the atmospheric air, and the off-gas that exit from the surface of the tank. And then the LESSDRONE measures the GHG concentrations. Regarding the measurement tests, we carried out 2 types of tests. The first is the point test, that is a measurement on several points in the oxidation tank with constant airflow, as constant as possible. On each point, the alpha SOTE and the GHGS were detected, and so the spatial distribution of the parameters were measured in the tank. The second type of test is called stationary test, and it's a measurement in a single point of the tank for an extended period of time, up to 1 week, under ordinary management conditions. So the parameters were measured in order to assess their temporal distribution in different operating conditions, such as working day or public holidays, or night or day, or during high or low load, and so on. In this image, you can see an example of measurement points that are the red points during a point test, and 1 point, the blue point in the center of the tank, for the stationary test. About the strategy for the use of the LESSDRONE, 6 measurement campaigns were conducted at Cuoio Depot Water Resource Recovery Facility in Tuscany, Italy, for the prototype testing phase, and then other measurement campaigns were carried out in 5 other plants in Italy. That were San Colombano in Florence, Rome, and the Reggio Emilia plants, and 2 plants in Netherlands, in Eindhoven and Tilburg. These other measurements tests are conducted to evaluate the technology, transferability, and the versatility in different contexts. The first case study was Quoiodepur plant. The Quoiodepur plant treats tannery and municipal wastewater. The size of the plant is significant from the point of view of organic load and influent flow, about 850,000 IE and 1.6 million cubic meter per year of tannery wastewater and 1.3 million cubic meter per year for urban wastewater. There are pre-denitrification, oxidation, nitrification biological reactors. The aeration system consists of membrane disk diffusers with a decreasing density along the flow in the tanks. The 6 measurement campaigns in Quoiodepur plant were carried out between May 2019 and June 2020. These are the measurements point during both point test and stationary test in 2 tanks, in 2 aerated tanks of the plant. This is an image of the LESSDRONE during a measurement campaign. The second case study was San Colombano plant. The San Colombano plant in Florence treats urban wastewater. It has a high capacity, about 600,000 IE, and a flow rate of approximately 200,000 cubic meter per day. It's a municipal conventional activated sludge plant with a denitrification-nitrification configuration. The plant is composed of 3 parallel treatments line equipped with 4 identical bioreactors. And the aeration system consists of membrane disk diffusers with a decreasing density along the flow of the tanks. In this plant, we carried out 2 measurement campaigns. The first in July 2020 and the second one in April-May 2021. Some observation on the point tests. The point tests were carried out in 3 different aeration conditions, so medium, low, and high aeration. Instead, the 2 stationary tests, 6 days long, were carried out, during which the LESSDRONE remained fixed at the central point of the aerated section. During the first test, the process aerating condition remain in the usual ammonia set point, while during the second test, the ammonia set point was modified. During the test, several samples were taken in different locations of the aerated and anoxic sections. These are the scheme of the measurements points in the aerated tank and an image of the LESSDRONE during a measurement. The third case study was Eindhoven plant. The Eindhoven plant is the 3rd largest in the country of Netherlands and is operated by Waterboard de Dommel. It treats the wastewater of 750,000 inhabitant equivalents, and the plant is composed of 3 parallel treatment lines equipped with a primary settler, 1 bioreactor, and 4 secondary sedimentation tanks. Each bioreactor is designed according to the UCT layout and consists of 1 anaerobic tank, 1 anoxic tank, and 1 anaerobic aerobic anoxic tank. The measurement campaign has been carried out in September-October 2020. About the typology of tests, there are 2 I-rated. Another observation regarding the I-rated tank, about the aeration system. There are 2 I-rated sections with the same membrane panel diffuser density. There is biggest aeration, that is the summer package, while the smaller, that is the winter package, is also present but not always in operation. For example, is in operation during rain events when the influent load increases. About the tests, we carried out 3-point tests in 9 points along the summer aerated section. They have been carried out in 3 different aeration conditions, so high, low, and medium aeration scenario. And 1 stationary test, 6 days long, has been carried out, during which the DO range was changed. So initially it was the ordinary one, then it was shortened. Again, several samples were taken in different locations of the aerated and anoxic section, as you can see in the scheme of this scheme of the tank. These are some pictures of the measurement campaigns using the LESSDRONE. And finally, the 4th case study was Stillborg plant in Nederland. It treats urban and industrial wastewater with a capacity of 380,000 IE. It has the nitrification configuration. The plant is composed of 3 treatment lines equipped with primary sedimentation tanks, 3 bioreactors, and secondary sedimentation tanks. The measurement campaign has been carried out in October 2020. The aerobic section of Stillborg plant is divided in 3 different compartments, divided by a septa with a lateral vertic opening. The aeration system is composed by membrane disc diffusers with a decreasing density from the 1st to the 3rd zone. The aeration is controlled by an ammonia DO cascade controller. About the point tests, we performed them in 9 points along the aerated tank, while 1 stationary test 3 days long has been carried out, during which the LESSDRONE remained fixed in a central point of the aerated tank. This is an image with the measurement points in the aerated tank and the points in which we have collected some samples for the analysis of the COD nitrogen fractions. These are some pictures during measurement campaigns in Stillborg plant. So here I have reported the average values of the oxygen transfer efficiency in the different campaigns. As you can see, for example, at Coyodepur, the alpha SOTE decreases from campaign 1 to campaign 6 because the diffuser's age increases and therefore their falling increases. As you can see in this graph, the average values of the alpha SOTE are in line with the literature data. And so this demonstrates the good results using the LESSDRONE. Here I have reported instead the average values of the GHG emissions. Some briefly observations regarding the direct emissions distributions. On average, the CO2 represents the greatest contribution compared to methane and N2O. However, in some cases, such as San Colombano, N2O increases and becomes more important. Indirect emissions were calculated on the basis of the electricity consumption for the aeration, and using the specific factor of the electricity production, so kilos of CO2 per kilowatt per hour. So we can observe that the direct emissions are greater than indirect ones. So the direct emissions are on average 85%. Versus the indirect that are the 15%. So thank you for your attention.